Good morning, children. Exercise 2.2 has two types of questions. Question number 1 has find the zeros of the polynomial and verify the relationship between the zeros and the coefficient. To find the zeros, we have already discussed the method of factorization, and for verification, we have already explained the rule. What is my suggestion to my dear children is, go through the videos of factorization as well as the verification of the relation between the zeros and coefficient, and try to work out exercise 2.2 question number 1 on your own, and then refer to the answers or today's video. Question number 1. Find the zeros of the following quadratic polynomials and verify the relation between the zeros and the coefficients. The first one, x square minus 2x minus 8. By splitting out middle term, product is minus 8, sum is minus 2. The factors of the product which gives a minus 2 is 2 and 4, which gives you 2 into 4, 8, and 4 minus 2 is 2. When the sum term has a negative symbol, it will go for the highest one and the other one will get the unlike sign. Thus the factorization, x square plus 2x minus 4x minus 8, x into x plus 2 minus 4 into x plus 2, x minus 4 into x plus 2, x minus 4 equal to 0, x is equal to 4, x plus 2 equal to 0, x is equal to minus 2. Let us call them as alpha and beta. Sum of zeros, alpha plus beta, is the same as 4 plus minus 2 is equal to 2. Product of zeros, alpha into beta, 4 into minus 2 is equal to minus 8. Rewriting the polynomial given and comparing the coefficients, the value of a is 1, b is minus 2 and c is minus 8. Minus b by a takes the value minus of minus 2 by 1 or 2. C by a takes the value minus 8 by 1 or minus 8. Thus, alpha plus beta is equal to minus b by a and alpha beta equal to c by a is verified. Therefore, alpha plus beta is equal to minus b by a and alpha beta is equal to c by a. Question number 2. 4s square minus 4s plus 1. This question can be done in two different ways. Those who can identify as the two square terms as 4s square and 1, a square value is 4s square, your a is 2s, b square is equal to 1 or b is equal to 1. You are checking whether the 2ab term as 2 into 2s into 1, which is equal to 4s, which shows that this polynomial is of the identity a minus b the whole square, or the factorization is 2s minus 1 the whole square, which shows that 2s minus 1 into 2s minus 1 are the factors. 2s minus 1 equal to 0, x is equal to half, and again s is equal to half. Call them as alpha is equal to half, beta is equal to half. Sum of zeros, alpha plus beta is equal to half plus half, which is equal to 1. Product of zeros, alpha into beta, half into half, 1 by 4. By rewriting the polynomial and comparing the coefficient a equal to 4, b equal to minus 4 and c is equal to 1, minus b by a is the same as minus of 4 by 4 which is equal to 1, c by a is equal to 1 by 4. Here also alpha plus beta is equal to minus b by a, alpha beta is equal to c by a is verified. The same factorization can be done by splitting out middle term 2 by taking the product as 4 into 1, 4 and the sum as minus 4, the factors being minus 2 and minus 2. Question 3. 6x square minus 3 minus 7x. It's a very important question. Arranging the polynomial in the standard form 6x square minus 7x minus 3. The product is given as 6 into 3, 18 minus 18 and the sum is minus 7. When the product is negative, the factors are of unlike sign and the factors are positive 2 and minus 9. Thus the factorization is 6x square plus 2x minus 9x minus 3. Taking the common factor 2x into 3x plus 1 minus 3 into 3x plus 1, 2x minus 3 into 3x plus 1 are the factors. The zeros are 2x minus 3 equal to 0, x is equal to 3 by 2, 3x plus 1 equal to 0 or x is equal to minus 1 by 3. Let us call alpha 3 by 2 and beta minus 1 by 3. Sum of the zeros alpha plus beta is equal to 3 by 2 plus minus 1 by 3. By LCM it is 6 into 3 into 3 into 2 into 2 or 9 minus 2 by 6 which is the same as 7 by 6. Product is equal to alpha into beta 3 by 2 into minus 1 by 3 which is equal to minus 1 by 2. By comparing the coefficients, A takes the value 6, B takes the value minus 7 and C takes the value minus 3. Therefore, minus B by A is of the form minus of minus 7 by 6 which is equal to positive 7 by 6. C by A is of the form minus 3 by 6 which is equal to minus 1 by 2. Thus, alpha plus beta equal to 7 by 6 minus B by A is also 7 by 6. Alpha plus beta is equal to minus B by A. Alpha beta is equal to minus 1 by 2. C by A is also equal to minus 1 by 2. Therefore, alpha beta is equal to C by A is verified. A similar question you can see as question number 6 which can be worked out on your own. This is a very important 3-mark question. Question number 4 and 5, I will explain the factorization. I will get the values of alpha and beta. The verification rule, please do it on your own. By looking into this polynomial 4u square plus 8u, it is not of any identity, or the easy method of factorization is you can just take the common factor 4u outside and the factorization is 4u into u plus 2. 4u, the zeros are 4u is equal to 0, which shows that u is equal to 0 by 4, 0, and u plus 2 equal to 0 shows that u is also minus 2. consider the value of alpha as 0 and beta as -2, and the verification can be done. Here A value is 4, B value is 8 and C value is 0 because constant term is not present. This factorization t square minus 15 can be done in two different ways. If you compare with the identity a square minus b square, this can be written as t the whole square minus root 15 the whole square, which shows that the factorization is t plus root 15 into t minus root 15. The zeros are t plus root 15 equal to 0 shows that t is equal to minus root 15. T minus root 15 equal to 0 shows that t value is also positive root 15. You can call alpha as minus root 15, beta as positive root 15, and the verification of the relation between the zeros and coefficients can be done. Here the value of A is 1, the value of B is 0 and the constant is minus 15. The second way of factorization is directly t square minus 15 is a zero polynomial. T square is equal to 15, which proves that t is equal to plus or minus square root 15, as positive square root 15 whole square is also 15 and negative root 15 whole square is also 15. So whenever you are getting an equation like t square is equal to 15, make sure that the value has a positive and negative square root, because the positive value of the square root whole square as well as the negative value of that value square root will be a positive number.